Okay, so at the beginning, I would like to talk about some technical issues or technical questions like requirement or something like that. And at the beginning, I'd like to introduce myself. I do hope that not everybody knows me. So I'm Andrei Krivoshabkin, and I do some archaeology in Central Asia. Me and my friend Recep Kurbanov from Moscow. Once we had quite a long evening talk. We discussed problems of dating, absolute dating of Central Asian Paleolithic sites. And Recep, he proposed an idea to invite well-known people to give a talk about dating, about problems of archaeology in Central Asia. At the beginning, it was the idea to invite people from our project, just like to do a kind of work seminar. And then when some of you know Recep and his ideas, and then that idea transformed to something bigger and excellent, and how to say, another Recep's word, okay. We decided to organize a seminar dealing with problems of Central Asia, not only archaeology, but like a complex study of that. Dating, anthropology, maybe some genetics, paleogenetics, and for sure archaeology. And we decided not to focus only on Central Asia, but try to put it in the context of general migrations, general problems. So as everybody of you already see in the program, we decided to start with the interesting, at least for us, topics dealing with anthropology, genetics, dating, some chemical and physical studies of our objects, and for sure we will finish with archaeology. Not only Central Asia, but try to understand how that region was populated, occupied by people, and try to make a focus on dispersal of modern humans. It's quite a fashion topic. So you have that program. I don't know, maybe it's not ideal, but it's interesting for us at least. We decided to start with the anthropology, just to have a general context, general ideas about human dispersals. And we invited Professor Bence Viola. He's also a friend of us, and we work together in Central Asia since, I don't know, I think at least 15 years, maybe more.
18 years.
Yeah. How many?
18, I think.
Okay. Anyway, somebody already finished school. So he will start this. He's very interesting person. That's why we decided that he will start. Otherwise, everybody will be bored. And now some words about technical questions. In YouTube, we will have only talk, Bence's talk, without discussion, without questions. So translation to YouTube will be stopped when Bence's talk. Here in Zooms, we will continue with discussions and questions. If somebody wants to ask a question, just write it in the chat. Not a question itself, but just to mark it. I want to ask a question. And after Bence's talk, we will start with that list. We will give first word to first person who marked himself willing to ask question, and so on. Similar pattern will be with the discussion. Also, if somebody wants to say some words in discussion, mark this in chat. That's it, I think. So let us start, and let me introduce Professor Bence Viola from Toronto University. Now, previously he had several other positions in also very famous universities. And Bence, go on. And okay, thanks to everybody for joining us.
Yeah, thanks, Andre, both for the invitation and for the introduction. Katja, can you make me the organizer so I can share my screen, please? Yeah, there you go. Okay. So good morning, or I assume for some of you it's already evening. It's morning here in Toronto. I would like to talk a little bit about late Pleistocene migrations into Central Asia today from an, I would say, very clearly anthropological perspective. I find it very interesting how this whole pandemic that we're going through at the moment is on a local scale, really isolating. You know, you can't see your neighbors, you can't go shopping and so on, you can't go to work. But on a global scale, it does allow us to collaborate much more. I find it absolutely amazing how many such international seminars are taking place. One could occupy, one could spend the whole day just looking at these. Yeah, so Central Asia is a very interesting region for many reasons. One of them is, of course, is that it's really a region of extremes. And I always found that fascinating. You find in Central Asia, and I use the word Central Asia here in a very wide sense. This is the UNESCO definition of Central Asia, which also includes southern Siberia. And I know that usually in the Russian use of Central Asia, it's more focused on the Central Asian republics. But Central Asia includes some of the driest and hottest deserts in the world, some of the highest mountain ranges. At the same time, also really more mosaic environments, like the Altai is probably an example. You have the mountains, but you also have a lot of steppe. You have the large Eurasian steppe belt as the kind of the northern half of Central Asia, which is important because it likely served as a route for dispersals. You have a relatively uniform environment from one end of Eurasia to the other. And finally, of course, to the north, this region is delimited by the taiga and tundra of Northern Asia. So you have a very, in the end, a very diverse environment, but most of it was likely quite extreme and not necessarily the easiest to inhabit. And as we'll see, this will be a recurring element. Many of the occupations that we have seem to be relatively limited. The first person to think about Central Asia as a region that should be explored to better understand the origin of humanity was Roy Chapman Andrews, who in the 1920s led the so-called Central Asian expeditions into Xinjiang, looking for the origin of humans. He was not successful. He hasn't found any human ancestors, but discovered amazing dinosaurs. So, you know, something good came out of it in the end. Of course, I would say the start of the scientific exploration of the Paleolithic of the region happened with Okladnikov, who worked among else at Teshiktash, but he also visited, for example, Selungur, where we work today. What is interesting is that Okladnikov's discoveries at Teshiktash, though frequently received just as, you know, just showing that Neanderthals were present there as well, were not necessarily understood that way by everybody. I always find it fascinating how Franz Weidenreich, who worked among else on Neanderthals from Germany, but also on the material from Chukutien and from Indonesia, described in a paper where he talked about Teshiktash, he said, the gap which separates the European Neanderthalian from Homo sapiens and led to the deduction that the former has become extinct without leaving behind any descendants seems to exist only in Western and Central Europe. Towards the east, intermediate forms emerge, which bear witness to the continuation of the human line of evolution. So he had a perspective that this clear cut or separation between Neanderthals and modern humans that we see in Europe which also is becoming a bit more blurry these days, is not necessarily present in Western Asia and in Central Asia. So let's talk a little bit about the sites. I'll try to limit myself a bit. There are, of course, really interesting sites a bit further to the west. All the sites in the Caucasus and in Western Asia. But here we'll talk just about the sites in what I would call the Central Asia sensu stricto, the Central Asian republics, so Teshiktash, Obi Rahmat, and Selungur. Then I'll also talk shortly about the few sites in the Altai, actually only 2 of them. I won't talk in detail about Okladnikov. And then about Ustishim, which is, I would say, already really in Northern Asia, but it's important because it yielded evidence for some of the first modern humans in the region. So, of course, the most famous site in the region is the Nisova cave. I think I know that many of you have been there and I assume that everybody has heard about it. I'm not going to talk about the archaeology and so on. What is important in Denisova is that we have evidence for several different populations. We have fossils from Denisovans, a population which for a long time we only knew from Denisova cave. We have a couple of teeth, finger bone, and more recently some cranial fragments that belong to this group, and that slowly give us a bit of an insight into the morphology of this group. On the other hand, in the site, we also have evidence for the presence of Neanderthals. We have a toe bone, Denisova 5, that is famous because it yielded the first high coverage Neanderthal genome. Little incisor, which actually we don't know genetically whether it's a Neanderthal, but I'm pretty sure it is. And the finger bone, Denisova 10, that is also a Neanderthal. And then most interestingly, we have a specimen that is neither Denisova nor Neanderthal, but actually a hybrid of these 2. Denisova 11, or Deni, is a tiny little fragment that was found using zooms, zoo archaeology using mass spectroscopy, that genetically could be shown to have come from an individual that had a Neanderthal mother, but a Denisovan father, which is really fascinating because it gives us evidence, number 1, that these 2 populations coexisted in the Altai. And number 2, it also gives us evidence that they interacted. Clearly, you can only get a new human being if you interact with each other. The question how these interactions exactly work is a relatively complicated one, and I don't think we can really tell. Sadly, due to the preservation of this fragment, which is it's not to scale here. In reality it's only 8 millimeters long. This fragment is extremely undiagnostic. It comes from some long bone. It gave us DNA, but beyond that, it's not very useful. So what we found out from all the genetics of Denisovans and Neanderthals in Denisova cave is that the ancestry of modern humans and the interactions between various human populations that were present in the Altai, but also in the rest of Eurasia, is much, much more complicated than we thought, even just 10 years ago. It's clear that whenever Denisovans, Neanderthals, and modern humans met and had the opportunity to interact, some gene flow happened. You have gene flow from Denisovans into various modern humans, into modern humans who live today, into the ancestors of modern humans who live today in Oceania. You have a little bit of Denisovan gene flow into present-day mainland Asian populations. You have gene flow from Neanderthals into the ancestors of everybody who lives outside of Africa today. There's been gene flow between Neanderthals and Denisovans. There's also been gene flow from what we call a potential unknown hominin, and I think most likely we could call it Asian Homo erectus, into Denisovans. And there's even a bit of evidence for gene flow from modern humans or the ancestors of present-day modern humans, into Neanderthals. We'll see, maybe someday we'll also find evidence for gene flow from modern humans into Denisovans. So what you see here is a very, very complicated picture of many populations that are in contact from time to time. But what is important is that despite this gene flow, these populations retained some kind of genetic isolation as well. So this is not that these two groups live together constantly. It's more, it looks more like they get in contact, there's some gene flow, then they get separated again, likely due to, you know, geographic and climatic factors. Another site in the Altai that is quite important is the site of Chigirskaya cave that Ksenia Kolobova is excavating more recently, and the excavations are still ongoing. Chigirskaya cave is especially important because it gave us the richest record of hominin fossils in the region. We have at the moment about 80 fragments of Neanderthals. At the moment, at least, it seems that the only hominins who inhabited Chigirskaya cave in the Pleistocene were Neanderthals. This is pretty clear from the morphology of this mandible, for example, that has an oblique mylohyoid line. The dental morphology as well. You have all these traits that are very typical for Neanderthals and not usually seen in modern humans, such as mid-trigonate crests, asymmetrical lower P4s, and so on. It's really a very, very typical Neanderthal population. Interestingly, much more typical than, for example, the material we have from Okladnikov cave. You also have the incisor shoveling that you usually see in European Neanderthals. So this upper incisor shows these very marked mesial and distal ridges and a large lingual tubercle. Really, based on the morphology alone, this population is clearly Neanderthal, but we also have genetic data. Just a few days ago, in collaboration with colleagues from the Max Planck Institute in Leipzig, with Fabrizio Maffesoni, Svante Pabo, and others, we published another high coverage genome of Neanderthal, in this case coming from a finger bone in Chigirskaya. And what is interesting in this case is that this Neanderthal, even though it's only about 100 kilometers geographically from Denisova cave, is genetically less similar to the Neanderthals in Denisova cave, or at least to the high coverage genome in Denisova cave, than it is to European Neanderthals. And what is great about this is that this really supports the idea that Ksenia Kolobova and many others, including me, published a few months ago, that Chigirskaya cave, or the Neanderthal in Chigirskaya cave, were the results of a second independent migration into the Altai. And we said this only based on the archaeological material. The lithics in Chigirskaya cave are very similar to the Mikokian that you find in Crimea, for example, or in northeastern Europe, and are very different from the archaeological material that's associated with Neanderthals in Denisova cave. What's interesting, though, is that the Neanderthals in Denisova cave are also variable. So the toe bone, Denisova 5, that is the high coverage genome, is a Neanderthal population that diverged from Chigirskaya cave, from the Chigirskaya cave Neanderthals and the European Neanderthals quite early, somewhere maybe 150, 200,000 years ago. But the Neanderthal that is actually the mother of Deni, of the Neanderthal Denisovan hybrid in Denisova cave, is much, much more similar to the Chigirskaya cave Neanderthals. So we see this region seems to be complex. You have one group of Neanderthals moving there, maybe dying out. One of the things we see in these Neanderthals are extremely low population sizes. They seem to live in very, very small groups that are isolated from other groups. And, you know, such small groups are in general prone to extinction due to climatic factors and so on. And then other groups come in and recolonize the area. And this seems to have happened repeatedly. I'm not going to talk about Opladnikov Cave, which is the third Neanderthal site in the Altai. But I want to talk a little bit about Ustishim, which is a site on the Irtysh River in Western Siberia, really at the very northern margin of what one could call Central Asia. What is remarkable about this site is that there actually is no real site. All we have is a hominin femur that was picked up by a collector in somewhere between 2008 and 2010 from the banks of the Irtysh River near the small village of Ustishim. As you can see here, this femur is not very well preserved. It's a bit beaten up, but its morphology is clearly modern. It is clearly a modern human based, for example, on the presence of what we call a pilaster, a marked bony ridge that you see here in the central image along the back of the shaft. What is also quite modern human-like is the strong flattening anteroposteriorly. So from the front to the back that you see close to the proximal end, so on the right of this image. What is remarkable, though, about this specimen is not only that it's a modern human, but also that it's a very, very early modern human. We don't have an archaeological context for it, but we have a direct date. And the direct date is uncalibrated 41,400 years BP, which if you calibrate comes to about 45,000 years, which at the time when we published this in 2014 made it the oldest directly dated modern human outside of Africa anyway. So we have here a very early modern human. One of the questions, of course, we wanted to know is how it is related to present day modern humans. And luckily, Ustishim had amazing DNA preservation, so we could actually look at the genetics of this individual. And what we found is that Ustishim is what we call a ghost population, a population that left no traces in later populations. Ustishim was part of the out of Africa migration somewhere between 100,000 and 60,000 years ago. But it does not seem to be related to any present day population. So in these so-called principal component plots, which are multivariate plots showing the affinities of various populations, Ustishim is the purple kind of star flower thing that is very close to the center of all eigenvectors. And this is interesting because this means that it's close to the common origin of all present-day modern humans. It's not related to present-day Asian populations. It's not related to present-day European populations, nor African or any other population. It's really part of this basal. It's really at the base of the radiation outside of Africa. So this is again evidence for one of these localized extinction events. It seems that this Ustishim population, these modern humans, came into Central Northern Asia 45,000 years ago, but then disappeared. And the region was later recolonized by other modern humans. So the next modern humans for which we have genetic data in the region are from far away, from Tianyuan Cave near Beijing. But they're only about 5,000 years younger than Ustishim. And 5,000 years after Ustishim, there's already clearly people related to present-day Asian populations in East Asia. Similarly, in Europe, you have, by about 38,000 years ago, populations related to present-day Europeans. So you have these events where a population moves in and then disappears again. And this likely happened repeatedly. But of course, we only have evidence for a few of them. So let's move down into what we'd call Central Asia sensu stricto. The most famous site probably is Tashiktash Cave, a cave in the Baisun Mountains of Uzbekistan that was excavated by Okladnikov in the 1930s. Sadly, at the time, he completely emptied the cave. So research by colleagues of Andrei in the early 2000s, I think it was 2003 that Anton Anoikin and colleagues went there to re-excavate the site. All they found was that all the sediments are gone and it's not even possible to redate it, which is really tragic. Because Tashiktash yielded amazing archaeological and anthropological material. Probably the most important find was the cranium and partial postcranium of a 10 to 12-year-old child that, according to the interpretation of Okladnikov and colleagues, was deposited in a circle of ibex crania. There's been a lot of discussion whether this was an intentional burial or whether it is simply a complete accident. Let's not go there. What is interesting about this specimen is that morphologically, to me, it's a pretty clear Neanderthal. Whether you look at the facial morphology, which has the puffiness and the so-called mid-facial prognathism we see in Neanderthals, whether you're looking at the dental morphology, it's all very Neanderthal-like. There are a few analyses done by Micah Glantz and colleagues and Terry Ritzman that indicates that there are also some similarities to some of the early modern humans, but I would say in general, Tashiktash is pretty much Neanderthal-like. Sadly, there's very limited genetic data from Central Asia sensu stricto. From Tashiktash, all we have is mitochondrial DNA, but the mitochondrial DNA we have from Tashiktash is Neanderthal-like. It looks exactly like what we see in European Neanderthals, but also, for example, in Okladnikov or the Denisova Neanderthals. So this was the first genetic evidence for the presence of Neanderthals in Central Asia. Another site that is important is the site of Selungur in Kyrgyzstan. This site is currently under excavation by Andrei Krivoshabkin, Tamerlan Charginov, and me. And it's a fascinating site because it's more or less the only site in Central Asia where we have reasonably good deposits of archaeological, paleontological, and anthropological material that seems to be, if not completely in situ, at least only redeposited within the cave. The hominin material was recovered in the 1980s during excavations by Utkur Islamov, who, together with Zubov, described 6 teeth and child humerus as up to 1.4 million year old remains that he referred to as Ferganthropus. The idea was that this is a Homo erectus relative. Not a problem with the material from Selungur is that the teeth, sadly, are not human. The teeth that he interpreted or that they interpreted as premolars are lower third incisors of cave bears. The teeth that they interpreted as hominin incisors are incisors of cervids, of deer. And so we have a bit of a problem. Despite the fact that, these are described as Homo erectus, they are animals. One of the traits that Zubov and colleagues used as evidence for them being human was the presence of these grooves on the interproximal surfaces. So between the teeth, you have these grooves. Similar grooves have been seen in various humans going back to likely almost Homo rudolfensis. The oldest evidence for these toothpick grooves is close to 2 million years old. they were interpreted as toothpick grooves, as hominins using stalks of grass or little twigs to kind of pick out little pieces of meat and other stuff that's stuck between their teeth. The problem is that actually similar grooves are also seen in cave bears. They're actually very, very frequent, exactly in the same region on cave bear incisors. They've been described as keilförmige Defekte, wedge-shaped defects in the 1930s. And similarly, it's also seen in deer. And the likely reason for this is that both deer and cave bears sometimes strip vegetation like grass between their teeth, and the abrasive, the silicates and the grass can abrade the cervix of the teeth. So the teeth are sadly not evidence for human presence, but the child humerus is. One of the limitations that we have in Selungur cave is that it's very hard to correlate the results of the excavations that we did in the last years with the excavations from the 1980s because Islamo's documentation is far from perfect, or actually for some parts of the cave it's practically non-existent. This humerus supposedly comes from layer 3 in excavation zone 5. We cannot actually relocate this in detail. We know where zone 5 is with a precision. It's an area of about 15 square meters. It was somewhere in there. What is interesting is that this humerus, though, is clearly human. It's close in size to a humerus we have from Okladnikov cave in the Altai. It's a Neanderthal. And also the somewhat more complete Ehringsdorf G humerus, which is an early Neanderthal from northeastern Germany. It comes from an about 10 to 12-year-old individual. But as you can imagine, interpreting the morphology of fragmentary postcranial bones is a little hard. You see it here in comparison with Ehringsdorf and Okladnikov. So Ehringsdorf is on the top, Okladnikov in the center, Selungur on the bottom. It has a few features that are quite typical for Neanderthals and are not seen in modern humans. One of them is the strong flattening of the distal part of the shaft. So the lower third, so roughly the portion that's preserved in Okladnikov is compressed mediolaterally. So on this image, so from the left to the right. In this image, it would be from the top to the bottom. And you also have a very narrow medial pillar, which is the bony ridge that delimits the olecranon fossa, this pit here at the distal end of the bone, which is very narrow compared to modern humans. The shaft is also extremely robust. The bone is very, very thick. Much thicker than what you see in recent modern humans of comparable age. So here, for example, is a plot of length, in this case, reconstructed length, of course, for Selungur, compared to the TACA, which is the relationship between the total area of the cross-section and the cortical area. So how much bone there is and how much marrow cavity there is in this specimen. And as you can see, in the case of Selungur, more than 90% of the area is taken up by bone, which is much, much, much higher than what you see in recent modern humans here in blue, or even in Neanderthals that you see here in red. So based on the morphology, all we can tell about the Selungur humerus, sadly, is that it's something archaic. We have no idea how the humerus morphology of Denisovans would have looked like. The only postcranial specimen we have from Denisovans is finger bone. And actually, this strong flattening, medial-lateral flattening of the distal part of the humerus is not seen in recent modern humans, but is seen, for example, in Homo erectus. It's seen in Turkana boy, and about 1.5 million year old specimen from present-day Kenya. It's also seen in some of the first modern humans, for example, from Jebel Hood. Jebel Hood 3, a child humerus, has this flattening as well. So it seems to be an archaic trait, but not necessarily diagnostic. Sadly, up until now, we have been unsuccessful in recovering any DNA from Selungur, both from sediments and from the bones. Of course, DNA would have helped us answer this question, but yeah, it was not possible. Finally, the last site, a site that is especially close to Andrei's heart, to mine too, Obi Rahmat in Uzbekistan. This site was also discovered in the 1960s and first excavated by Rustam Suleymanov. And then since 1998, I think, Andrei has been excavating there till the late 2000s. Obi Rahmat is an amazing rock shelter with a long sequence of middle Paleolithic layers. I think Andrei will talk much more in detail about it later in a couple of weeks. What is important is that the lithic industry we see in Obi Rahmat is quite different from most other Central Asian industries. It's a blade-based Middle Paleolithic and shows quite a few similarities with the Near East. And so Andrei and some have interpreted this as evidence for contacts with the Levant. The hominin material from Obi Rahmat comes from a single individual. It's all fragments of a single juvenile cranium of, and again, about 8 to 11-year-old, likely male individual. We have 6 teeth. We have a bunch of fragments of the temporal bones, things like both Petrus pyramids, parts of the external auditory meatus, and we also have a reasonably complete left parietal that we can compare. There's another about 150 small bone fragments that we could not easily reconstruct to any other part of the cranium. We should probably revisit this at some point. Morphologically, the material from Obi Rahmat is, at least if you look at the dentition, again, very Neanderthal-like. So this upper second incisor shows very strong shoveling and is in size and shape quite similar to what we see in Teşiktaş, for example. You have a marked lingual tubercle. Metrically, it's not easy to compare this specimen because, of course, it's a bit broken. But I would say nobody would be surprised to find this in Europe or in Crimea and assign it to a Neanderthal. Yeah, here's a metric plot of the mesiodistal versus buccolingual diameter of this specimen. The buccolingual diameter, of course, had to be estimated because it's broken labially. But as you can see, it falls into the range of variation of the Neanderthals here, the red triangles, and is much larger than what we see in Upper Paleolithic or recent individuals. I'm kind of skipping the premolars and canine here. They are much less diagnostic. But the first molar is remarkable. It's a beautiful tooth. It's still probably one of my favorite hominins. It has a very marked hypocone. This cusp here, in occlusal view on the top right, you have this cusp that is very large, and it's projecting distolingually. And this leads to an occlusal outline that, instead of being kind of square, is somewhat skewed, like a parallelogram or so, or rhomboid. And this is a morphology that is very typical for Neanderthals. We don't see this in modern humans frequently. In its size, it's not very remarkable. It's like a large Neanderthal. Another tooth that is fascinating is a tooth that we think is likely an M3. As you can see, it's not very well developed. It's extremely large and has a very complex occlusal morphology. We spent a long time with Micah Glantz and Tatiana Chikisheva thinking about how to interpret this tooth. And in the end, decided that it's likely a pathological specimen. And this part here, on the top right of the occlusal view, is likely an accessory tooth that's fused to the germ, and this is known as the pathology in present day dentistry. It's referred to as gemination. We looked at it a bit more in a bit more detail with Tanya Smith, and that seems to be the best interpretation. This tooth is absolutely enormous. It's actually the largest. I mean, the teeth from Denisova cave and Denisovans in general had enormous teeth, much larger than normal Neanderthals. This one, Obi Rahmat, was even larger than those. It's the red triangle on the very top of this plot. As you can see, other Neanderthal M3s are enclosed within the red polygon on the left bottom. Few of them reach sizes over, mesiodistally over 11 millimeters. Obi Rahmat is about 16. It's really an enormous tooth, but because it's pathological, it's not very useful. The left parietal is interesting. Even though it was very fragmented, we could reassemble it with reasonable confidence. It's quite gracile, it's thin, but of course, this is a young individual based on dental development. We can tell it's 8 to 11 years old. What is remarkable about this parietal is its length. In general, Neanderthals and other archaic humans have relatively short parietals compared to recent modern humans. Their cranial length is mostly influenced by the length of the frontal and of the occipital. When you plot the parietal chord and arcs, so the direct measurement of the length and the measurement along the curvature of the Obi Rahmat parietal, it falls far outside the range of variation that you see in Middle Pleistocene specimens, in Homo erectus, in Neanderthals, and actually is closest to an early anatomically modern human, another juvenile. It's Kafze, I think it's 15. The green dot next to Obi Rahmat. So this is remarkable because, of course, we are comparing here at 8 to 10 or 9 to 12-year-old boy or juvenile to adults. So we are being conservative here. Clearly this individual could have grown longer in theory. It for sure didn't become shorter in its growth. And this is an indication that its morphology was not completely Neanderthal-like. At least its parietal and likely its brain might have been closer to modern humans, which is quite fascinating. We also looked at the bony labyrinth, at the inner ear of Obi Rahmat. And this region is important because there are very clear differences between Neanderthals and modern humans in this area. When I did a principal component analyses, Obi Rahmat plotted relatively close to Neanderthals and Middle Pleistocene specimens, and outside the range of variation of recent and upper Paleolithic modern humans. So we have an individual here that shows an interesting mixture of morphologies. You have some traits that are quite Neanderthal-like. You have a few traits that are not at all Neanderthal-like. Since this specimen was found, we always hoped that one day we'd be able to get DNA out of it. Sadly, that has been unsuccessful up until now, even though we tried teeth, we tried bone fragments, we tried even the petrous portion. Sadly, it's just not possible. The climate in the Central Asian republics seems to be much less well suited to DNA preservation than it is in the Altai, both in sediments and in bones. Okay, so after looking at all these specimens, you know, in a very, very cursory way, what can we actually tell about what kind of migrations might have happened into Central Asia or also out of Central Asia? So, you know, what is clear from the genetics is we likely have a complicated picture here. We have various populations that are in contact, and in some cases, we know that this contact happened right in Central Asia. We know the Neanderthal-Denisovan gene flow happened in the Altai, or at least also happened in the Altai, because we have evidence with Denisova 11 for this gene flow happening. What I think is important to keep in mind, though, is that, at least in my interpretation, Central Asia was likely, or at least large parts of Central Asia, was likely never kind of a core area of permanent habitation of hominins. I really think that in most cases, hominin groups came into Central Asia, were there for a while. You likely had very, very small population sizes, and if something happened, whether climatic events, could have also been some kind of disease and so on, these groups disappeared. Genetically, both at Denisova Cave and Chigirskaya Cave, where we have good genetic data, these Neanderthals lived in extremely small groups. They really were on the brink of extinction, I think, most of the time. We can't tell this for Central Asia sensu stricto, but I think the situation was likely relatively similar. In good climatic situations, you had groups move in, but when the climate turned more severe, they likely disappeared. Eller and colleagues proposed in 2004 to model early hominin populations as sources and sinks. Some areas where you have people surviving for long time periods and really thriving, and some areas where people move in only from time to time, and then go extinct. This was later on picked up by Dennell and colleagues as well, who talked about the Altai, for example, as a sink. I think in general, Central Asia was likely a sink. It likely went through repeated local extinctions and then was recolonized. But what is, I think, special about this region is that despite these repeated local extinctions and recolonizations, these recolonizations happened from different directions. And so it also served as a region where these different populations met and hybridized. And for me, the big question is, you know, did these hybridizations, did this gene flow then spread out into the core areas? Did Neanderthals that picked up some Denisovan traits, were these traits or were these genes later on transferred back into the Neanderthal core area in maybe the Levant, maybe in Europe, or was this something that we only saw in the Neanderthals in Central Asia? Similarly, if the Denisovans picked up some Neanderthal DNA, was this transferred into Denisovan populations further east or not? I think this is an interesting and important question, and I hope that at some point we will be able to tell that. So if you look at Neanderthals, it's pretty clear that there have been multiple migrations into the Altai. This is archaeologically clear and genetically as well. And at least for one of these migrations, for the migration that is the origin of the Chigirskaya population, the likely origin for them is Eastern Europe. The the lithic industry we find in Chigirskaya is quite similar to the Mikokian that we see in Crimea and in Eastern Europe. For Central Asia, we have much less of an idea. In part because we have less material, both anthropological and genetic data. But I think it's also likely that there have been different migrations into this area as well. We at least seem to have Neanderthals carrying or bearing different industries that seem to be different populations. For the Denisovans, one of the questions is really whether Central Asia was part of the Denisovan core range where they permanently lived. And originally I would have said probably not. Now I'm a bit more open. I think it's hard to tell. So the only other site where we have proven evidence for the presence of Denisovans is Xiahe on the Tibetan plateau in China. And this mandible is in a cave at very, very high altitude, over 3,000 meters. There's also some genetic data. There's a study that showed that a genetic adaptation that is very frequent in present-day Tibetan populations, that is an adaptation to high altitudes, came into them via gene flow from Denisovans. So this raises the possibility that Denisovans were a group adapted to high altitudes. Now, if they were a group that was adapted to high altitudes, you'd expect that they lived in these mountain ranges of Central Asia. The problem is, though, that in Central Asia, at least, outside of Tibet, we have very little evidence for an occupation of high altitudes in the Middle Paleolithic. Selungur is probably one of the only sites. Selungur is at roughly 1,900 meters. It's probably the highest elevation Middle Paleolithic site in the area. I think that we need to look harder. We need to look at higher altitudes, and it would be fascinating if we would find evidence for hominin presence, and in that case, in my opinion, likely the presence of Denisovans at these high altitudes. Either way, I think that the presence of Denisovans in the Altai is evidence that there were genetic connections towards the Far East. We're currently working on better understanding, at least how, based on the morphology, whether some of the material that we know from Eastern Asia, from China in particular, might actually be also linked to Denisovans. There are a few good candidates, such as Shujiayao, for example. So what about modern humans? This is, of course, the big question, and I would say the hardest question. So one study by Kuhlwilm et al. Looked at the Altai Neanderthal genome, so at the genome of Denisova 5, and using a mixture modeling method, found that there's some evidence for gene flow from a population that is basal to all present-day modern humans into the Altai Neanderthals. So this here on the left of this image, it's the red arrow that says 0.1 to 2.1%. Now, this would be fascinating. I think there would be several possible interpretations. One could say maybe this is fascinating because this Altai Neanderthal, Denisova 5, is at least 120,000 years old. So one possibility would be, that this individual, that modern humans came into Central Asia and somehow were in contact with the ancestors of this individual. This is a possibility, but of course, another possibility is what if these kind of contacts happen in the Near East, and then you had Neanderthals that mixed with modern humans in the Near East that migrated into Central Asia. Another possibility is that this is a spurious signal. We don't seem to see this signal in Chigirskaya cave, for example. I think it needs to be looked at in a bit more detail. There's also some archaeological evidence. I mean, Andrei will talk about it in detail, but Andrei, for example, has the impression that some of the lithic material from Obi Rahmat is quite similar to material found in the Levant at sites like Mislia. Now, I have not studied the Mislia remains personally, but based on the photographs that are published and the descriptions, Mislia is very clearly a modern human based on its dental morphology. And Obi Rahmat is not. What we see in the dental morphology of Obi Rahmat is much, much more similar to Neanderthals. And you can see this if you compare the first molars here. Mislia has a tiny and non-projecting hypocone. And the third molar in Mislia is especially diminutive and really reduced. Mislia's dentition is really very modern looking, especially for its age of 160 to 180,000 years. So I think morphologically we can't tell. The first clear evidence for the presence of modern humans, I think, is at Ustishim around 45,000 years ago. I think that's undoubtable. It's possible that modern humans were in the Altai around the same time as well. There's some archaeological evidence at sites such as Karabom for that. But, you know, we don't have any human remains. So I would say currently there is very little to no evidence for early migrations, so pre-initial Upper Paleolithic migrations of early modern humans into the region. But, you know, I think we should be very careful. If we think back 10 years ago, we didn't know about the Denisovans either. We had no idea that this population was out there. And you know, our views have been completely transformed since 2010. So, you know, I'm open to it, and I think it would make the story much more interesting and exciting if we found modern humans or evidence for modern human migrations into the region. So that's it for me. Thank you very much. I would like to thank lots and lots and lots of people who have helped me in various ways, who have talked to me and discussed various things with me over the years. And especially, of course, to Andrea and team, not just for this invitation, but also for our collaboration that's been ongoing for, yeah, I think it's 17 years now, since 2003. And it's been an awesome ride, and thank you very much.
Thank you, Bence.